Uh, Welcome everyone who's watching the recording later on. We are today trying to start with Python basics. I'm here today joined with my friend also, Yevgen. We are trying to learn Python. In addition, we will be taking a look at some problems from bcrowd later on. Uh, Mainly, we'll try to dissect one problem from bcrowd because Python has a lot to offer us in terms of support library. So actually, one of the main things that we need to know is how to use the built-in functions properly, so we can save time during the competition. Starting from next week, I hope that most of us will be able to meet on daily basis because otherwise it will be very difficult to score an acceptable score in the competition. Okay, we are aiming to solve at least 1 to 2 problems per team. Okay, uh, and like it's not a high target, but still it needs to be challenging a little bit as there are many teams actually competing. Okay. Now, starting with Python, the setup is very simple for Python. All you need to do is install Visual Studio Code. And after having Visual Studio Code, you need to go to extension and look for the Python extension. This Python extension will provide you with IntelliSense. That's the main point. It doesn't actually provide you with Python environment. Okay. In order to download Python environment, you can get it if you are on Windows. You can get it from the Windows Store. Just go to the Windows Store and type Python 3, and then you can download it. Actually, if you type Python 3 on Windows machine using Visual Studio Code and hit enter, if Python 3 is not installed, it will take you to the store directly. So I think this is actually the easiest way instead of opening on the store. If you are using Mac, on the other hand, Python 3 will be installed for you from the get-go. You don't need to install anything additional. Okay. Now, when it comes to basics, usually I start with the Hello World program. Uh, Hello World program prints out Hello World only. So with the first thing I need to write is the print statement. Print statement, you can think of it as it is printing a value to the console which is the terminal you can see below here. By the way, this terminal, if it's closed for you, you don't see it, you can open it using two ways. Either using, I forgot the process actually, because, yeah, control and the tick mark, control and the tick mark in Mac. And to be honest, on Windows, I don't know. So otherwise, you can go to View and then Terminal also in Visual Studio Code. So View Terminal, it will open Terminal in the current project. In order to have a project like this one that I'm having, it's very simple. Let me actually start a new project. I don't do this project now. In order to start a new project, all you need to do is basically go to this tab, Explorer. Let me close this project. I don't want that. It will be empty this way. Okay, so you can hit on Open Folder and then select any empty folder. You can create a new folder. For example, I'll call it KCPC training, and then click on Add. This way, you have the folder ready for you. Okay. Let's start by creating a new Python file. I'll call it main.py. And you can see like the icon of the file now displays the logo of the Python language. If you want to display this icon the same way I'm having, also you need to install another extension. I believe it's called file icons. It's either file icons or I have another one actually installed for you. Let me tell you which one I'm using. Actually, I'm using VS Code icon. So it's up to you. It's all just a way to easily identify the files that you have in your project. So, for example, if you have a picture, it will show another thumbnail here. Okay. So this is for the, we can say, the two main extensions that we'll be using. A third extension actually would be Prettier. Prettier is good for auto formatting the file. Okay, Prettier for formatting. So I don't think you'll need another extension. These three should be more than enough. Okay. So back to our Python code. Print, as we mentioned, will output a value to the terminal here. The moment I run the program, so uh, print alone, of course, we can uh, print out a string here. There are two ways to print a string. Hash, by the way, it's a way to add comments. These comments are not visible to the compiler, or in this case, the interpreter for the Python language. The interpreter ignores the hash and actually also ignores the triple quotes and the strings. Okay, so these three are ignored. They are not processed by the compiler. Okay, you can type whatever you want here, and it will have no effect whatsoever on the functionality of the program. Okay, so this is regarding comments in the Python language. So you can either write multiple comments, of course, by adding uh, the hash sign and then adding maybe comment one, comment two, comment three, and so on and so forth. You can also add a comment here. Now, what's the difference between this and this? Of course, if you try to add multiple lines here, it will break. Okay. So in this case, if you want to add multiple line comment, it is a very common convention actually in Python to use the triple quotes this way. Okay. And then you can add multiple lines or as many lines as you want. Okay. So either way, you want to use this method for adding the comment or this method, it's up to you. Okay. In the end, the output is the same. So let us print hello world this way. And to run this program, you can go here to the play button in the top right corner. It will say run code, or if you want to debug it also, the same way. Now with debugging and tracing, this goes step by step actually. Let me just run it first and then I'll show you tracing. So if I run it, I can see that it printed out on the console, hello world. Okay, and this is the command they use to run the program, Python, and they specified the file to execute with dash u. Okay, and the file is contained in this directory, which is map desktop KCPC training main.py. So in theory, you can actually use the same command to run the program. You don't need to keep pressing the play button. So how did I do that? I just use the up arrow key to view my history, the command history that I have here. And then I pulled out the command that the play button used. Okay, in this case, it is Python -u. And then I run the program again. And this might be easier way to run the program multiple times. Okay, now when it comes to debugging, we can set a breakpoint here in Python, and then use instead of the play button debug Python file, and you can see that it printed hello world, but it didn't print hello world 2. Why is that? Because I set the breakpoint on this line. So essentially, this is telling the compiler, okay, or the interpreter, please execute this line. And when you reach this line, please take a break. Let me examine the program status, and then uh, uh, like when I hit continue, then I'll allow the interpreter to move on to the next line, which is this line. Okay. This will be extremely useful for debugging the program. If you face an issue later on or unexpected behaviors started to appear in your program, you can use the debugger this way. Okay, so when it comes to printing, it is as simple as that. Okay. To print a string, it's basically print and then hello world. Okay, what if I want to print a number? The same goes, uh, just I need to remove the double quotes and just add my number between the parentheses. And remember, print is actually in this case a function, okay, and it's taking this number 2 as a parameter. Okay, we'll cover functions later on, but for now, just know that it is a built-in function. Okay, and you can see it defined here. And actually, if I want to see it on the source code, in the source code of Python, I can hit the command button on keyboard. I think in Windows it is the Windows key, and click here. And actually, I can see how is it defined. Okay, and if I want to see the actual source code for the print command, I can view it here. So it is a very useful way to, if you are using a third-party library and you would like to know how is it working, this is an excellent way of what examining the source code of that library. Okay. The same applies if you import any third-party library, and this is one of the most powerful features of Python is that it is like the open source nature of its support library. Okay, it's nothing hidden. Like at any time, I can just hit the command key and view the function. If it's built-in function, it will take me to the support library path. In this case, it is stored here in the actually it's supposed to be in the Python folder, but I think they have some way of mapping it. Okay, it's supposed to be in the Python lib folder. Okay. But anyway, so printing numbers and printing strings is almost the same. Okay, just the difference is the double quote. So what if I want to print two this way? What is the difference between printing two here and two here? Essentially, for the naked eye, as they say, there is no difference because will be both of them will be printed the same way. Let me go back to my function. Both of them will print the same, but actually there is a hidden difference between them. So this hidden difference is only visible to us, the programmers. If I try to concatenate 2 plus 2, for example, okay, now what do you think the output will be in this case? Like the first line versus the second line. The first line, what do you think it will be? Okay, 4, and then an error. Okay, let's see. Okay. Actually, it is a very famous behavior that you are right. It is not possible to concatenate, and this is, by the way, this is the name for it. Concatenate. It's a long word. Okay. Concatenation. But concatenation is basically putting two strings together. Okay. So from the name, two strings. Both of them need to be strings. So you can see now the difference. Two here is treated differently than the two here. The string two cannot be combined with a number two, while the number two can be combined with another number like it. Okay, then what is the solution? The solution is casting. Okay, casting in Python is very easy. Of course, in order to cast something, you need to know what are the available data types for you in Python. So we have integers, we have floats, we have Uh, I think they call it booleans. Okay. Um, so let's start with these for now. Okay. We have many data types actually, but when it comes to casting, and of course strings. Okay. So let us try to cast one of them to the other. What do I mean by that? We have a string and a number. So either we cast the number 2 to a string or the string 2 to a number. Okay, let us try. In order to cast a string to a number, we can use the following format: integer and then parentheses. And inside the parentheses, you can see that, of course, the Python interpreter or the IntelliSense extension already is trying to help me display the pop-up, and it's telling me, by the way, if you use integer this way, then you are trying to convert something to something else. Okay, and you can see that it's giving us even an example here in this case, which is excellent. Okay, so let us try to cast two to integer. Okay, I'll remove this two and try again. In this case, we got the expected output, which is actually a combination of 2 and 2. Okay, what if I want to do it the other way around? Now, if you want to do it the other way around, there are multiple ways. Okay, for me personally, like you can use the format option. So if and then include the two here. Okay, this is one of the easiest way, and it is like supported, I think, from Python 3. Starting from Python 3, they support the formatting of strings this way. So in this case, it's basically I'm saying format this string, and please pay attention that anything included in the curly brackets is not actually a string. It might be a variable or a formula or anything else but a string. Okay. So in this case, if there is anything included between the curly brackets, it will be treated as something else. So in this case, okay, what do you think the expected output will be? So 2 plus then format 2 plus 2.
Or maybe 2-4 or 24.
2, 4. Okay. Okay, let's if we want to break it down to multiple steps. Okay, for now let us execute it as is. You are right. It will be the number 2 concatenated with the number 4. Okay, and for us it looks like a 24, but actually it is actually a string. Yeah, string 2, string 4. But the console doesn't differentiate between them. Like it will print it the same way either ways. Okay, so if I print, that's what I'm trying to say. If I print 24 this way, you can see there is no difference for us between this 24 and this 24. Okay, and this is actually very important during solving B crowd problems. Is that as long as it looks exactly the same way that the problem is expecting the output to look like, then it doesn't matter if it's a string or a number or whatever. Okay, you just need to look exactly as the problem output or expected, yeah, expected output. Okay, so this is for printing with formatting. Okay, let us actually move on to floats a little bit. Okay, because it's one of the data types that we'll be using very often. Okay, so floats are different from integers in a sense that they, when it comes to integers, they don't contain a decimal place. Okay, they are a whole number. They are called whole numbers. Okay, whole numbers it's like 100, 1,000, and so on and so forth. Okay, while floats can contain decimal place and will be represented this way. Okay, 1.23, for example, is treated as float in Python. So in this case, let us try to print a float first, 24.5, for example. And the output will be like what you expect, uh, which is 24.5. Nothing different. Okay. If I combine floats together also, it will work exactly the same. Okay. The output will be another float. So what if I combine 24 with 44.5? You can see that it is still a float. And it's trying to tell you that it is a float by adding a zero decimal place. This is the hint it's trying to give you. So if you want to define 24, for example, as an integer or 24 as a float, the only way to differentiate between them in Python is to add a decimal place. So this will be treated as an integer actually, because Python does not have implicit explicit data type. It guesses the data type from the value itself. Okay, so if you give it something between double quotes, it will tell you, based on my knowledge, this will be a string. If you give it true, for example, it will tell you, based on my knowledge, this true is a boolean. If you give it 24, a whole number, it will tell you, based on my knowledge, my guessing, I guess that this number, you meant it to be an integer. And if you give it a hint that it is 24.0, then it will also capture that gesture and tell you, okay, based on my estimation also, you want this 24.0 to be treated as a float. Okay. So this actually brings us to our next segment, which is declaring variables in Python. Declaring variables in Python is very easy. Okay, you just need to start with the variable name, and then the assignment operator. This equal, we call it assignment operator, and then the value, and that's it. Okay, and you can see like in all my Python code, um, for those who are coming from other languages, I didn't include any special characters at the end, like semicolons. Okay, semicolons can be used in Python, by the way, and the program will work the same. But their usage is often not required. Okay, and mostly it is actually not used, but it is there if you want to use it. Why would you want to use it? If you want to do something like this, for example. Okay. Now, if you remove the semicolon in this case, you will get an error. Okay. So this is one of the use cases when you want to combine multiple lines in one line for whatever reason. Then the usage of semicolon becomes a necessity. Otherwise, in a normal program, actually, we usually write every statement in a line alone. And this is, and each line, by the way, we call a statement. Okay. Each line in any language, in any programming language, is called a statement. Okay. So this is how we declare a variable. So number in this case, this will be treated as what? Integer. And if I declare number 2, and this is also a valid naming convention, you can use numbers in the variable name. You can declare it as a float this way. Okay, so this will be treated as a float. And if I use bool, for example, or let us use true or false, And this is another naming convention in Python where you can use what? Underscores. Okay. And they call it what? They call this snake case. Okay. So snake case, you can see that it looks like a what? Snake. Okay. Uh, where each word, it is all small case, of course, and each word is separated by underscore. Of course, there's a reason why we use underscore in this case, because if I try to do this, you can see that the interpreter is not happy, or the IDE in this case is not happy with our code, because it tells you, okay, I understand that you are trying to do something here, but it does not look like variable declaration or function or if condition. It does not represent anything familiar to me. Okay, and that's why we can see the squiggly line. The red squiggly line now is appearing because this is actually incorrect way of declaring variable names. Variable names cannot contain space. Okay, so this is a rule of thumb in all programming languages. That's why we either use underscore or we use something else called camel case. So true or false. Camel case is another way of, or another convention of declaring what? Variable names. For Python, it is actually mostly common to use the snake case for Python. Okay. Camel case is less prevalent, we can say. Okay, so this is when it comes to integers, floats, and booleans. And this is how we declare them. Okay, as the name implies, variables can change through the lifetime of the program, meaning that number can start with 24 and I can print the value of number using the print statement. Okay, this way. Let me actually comment all of these. I don't need them. If you want to comment multiple lines, you can use the shortcut Control K, Control C. To uncomment multiple lines, Control K, Control U. Okay. Sorry, Command in Mac, and I think Control in Windows. I'm not mistaken. Okay. So in this case, I commented all the lines. I have my numbers with me. And then I used print. Of course, once I commented these lines, they will not be executed. Now I'm using print to print number. So I assume some of you might think that it will output number like this, okay, which is not correct. Actually, it will output the value of number. The value of number is based on the declaration that we did. Sorry, the declaration plus assignment that we did. This is another topic. Okay. Some languages separate declaration and assignment. Okay, where you can actually say number this way, and then use it later. Number equals 24. Okay, with Python, it doesn't like that. Okay, and I think if I try to run this, actually, it might throw an error. Yeah, it will throw an error. Python does not allow declaration with an undefined value, unlike C++, for example, where you can say int number and that's it. It is possible in C++. While in Python, it needs to know the value beforehand. You need to put something inside. Okay. In this case, you can put 24 as an initial value or 0 if you'd like as an initial value, and then alter the value later on. And that's what I'm trying to do here. Let me actually remove these so it will be clear. So I declared number and I gave it value of 24. And then I printed out the value of number. Then look here what I will do. I will change number to be hello world. And then I'll print number again. Okay, and let me set a breakpoint here, and let us actually debug this program. Okay. Now, it is clear that in the first step, number will be printed as 24, which is the normal scenario. Okay. But what do you expect will happen here?
So it's allowed to change the type that will print the new value.
Do you think it is allowed?
Uh,
Okay. Okay. Now, Wallahi, Python is a very forgiving language. It tells you you want to put a string inside a number and then change it to Boolean. It is okay with me. Okay, and that's why people like it. Yeah, okay, because it is very flexible. Yes, and you can see here number. By the way, if I highlight over it, it's telling me it's integer. Now look here, the magic. What will happen when I press continue? Suddenly, number became str. Okay, and this is possible, which is both a good and a bad thing. Okay. Now, when you define something as an integer, you expect it to remain as an integer throughout the life of the program. Actually, it is not a good practice to change the data type inside the variable during execution. Okay, so it is possible, but that does not mean it is a good practice. Okay, so in this case, it is better if we stick to one value type, meaning that instead of assigning a string, I can just say 25, for example, and then let us run it actually, no need to debug. We can see it printed 24, 25, and this is the normal behavior. A variable is expected to change throughout the lifetime of the program. However, what we don't expect to change is a variable type. Okay, so let us try to stick with this convention as much as possible. Okay, so this is, as we mentioned, it's called assignment operator, the equal. Okay, what if I told you there is another operator that is similar to assignment, which is plus equal? Okay, plus equal actually, it will increment the number by 1 in this case, and then store the value again in number. Okay, so in this case, if I try to run the program, it will print what? 25. Okay, and the same goes with minus. Okay, and now we are entering the arithmetic world of Python. Okay, so there are many mathematical operations that can be performed. We'll go through them one by one. So this is, as we mentioned, of course, you cannot do plus from the get-go because number didn't have a value to begin with. Okay, so you need to define it first and then do the incrementation or decrementation as needed. So this is essentially is equal to what? This is equal to number equals number minus 1. Okay, and if I do this also, okay, these two lines are equivalent. Okay, but you can see that one of them is more compact and the other is what? More verbose. Okay, and it's up to us to use whichever way we like. Actually, it is maybe in the beginning, as because most of you are still learning the language, maybe this will be easier to read. But with time, this will become actually the preferred way for most of you. Okay, because it is decluttering the code. The more decluttered the code is, the easier it is to read and decipher. Okay, so this is for incrementation and decrementation. Okay, what if we want to do other mathematical operations? We can do this actually. I have a file here. Let me, or because I don't want to miss any of these operators. Let's go through them one by one, and then later we'll see. So for this, I actually need two numbers. I'll call it number one and number two. just to make it simpler. So let's start with 2 and 4, for example. Okay, what operations we can do? In math, we have the plus, which basically is adding two numbers together. So number 1 and number 2. Okay, and then we have the minus, number 1 minus number 2. And we have multiplication, right? Addition, multiplication, and we have the division also. Okay, and actually here, let me reverse them because we are going to get into another concept in Python, which is the modulus. Yeah. Okay. So let us try to guess the output of each of these lines before we actually execute them. So plus, I think it's pretty straightforward. Number 1, if I double click on it, it is highlighting number 1. It is 2. Number 2 is 4. So this is what? 6. Okay. Same goes for here. Number 1 is 2. Number 2 is 4. 2 minus 4 is minus 2. Number 1, again 2, 4. Number 1, 2. Number 2, 4. Multiplication is 8. Division, when I divide 4 by 2, I get 2. Okay, so this is the expected output for this. And this is, I think, pretty much straightforward for most of us. We are all familiar with the basic mathematical operations. Okay, now it gets a little bit tricky here and here. If I remember correctly, it was this. Okay. Now it gets a little bit tricky with modulus and this symbol. Okay. So modulus here, modulus is basically the remainder of the division, and it is represented by percentage sign. Okay. So what is the remainder of dividing 4 over 2? 0. There is no remainder. Okay. Because 4 can be divided equally over 2. Okay. But what if I try to divide 5 over 2? 1. Because if I have 5 apples, as they say, okay, I can give each person 2 apples for them to be equivalent, and then I'll have 1 apple remaining that I cannot split in half. Okay, we can say it this way. So this one, I cannot split it in half because it will spoil the apple. Okay. Okay. So in this case, it's just another way of thinking of modulus. Okay, is that they have to divide equally, and any remainder will be the output of this operation. Okay, and usually the remainder is 1 in this case. Okay, which is 5 over 4. 5 over 2. Okay, what about this? The double multiplication. What do you think it means? Correct. Correct. It is the power. The power which is بالعربي الأس. تمام. أس 2. It's the power of 2. Right? Power of 2. That means it is the number multiplied by itself 1 time. Okay. Power of 3. That means it is multiplied by itself 3 times. So on and so forth. Okay. So this is the power, and this is another actually common mathematical operation that you're going to use during the programming context. And it is highly likely that it will be present. Okay, because these are we can say two big. Okay, so number 3. What is the power of 5? power of 2 or 5, 25. Okay. Let us run the program and see the output in this case. And we can see that we got most of the answers correct. Actually, not all. Can you spot the difference?
The one. Okay, you mean the 2.0?
Correct. Correct. Actually, here, division, the division operator produces a float, not an integer.
Yes.
Okay. The division operator produces a float. Okay. It might look minor, but actually this will affect the behavior of the program if you are not careful. Okay. So all of these, even though the two numbers we initially started with were integers, produced an integer, except for division, where it doesn't matter if you use a float or an integer or whatever, it will always produce what? A float. Okay, so this is a special case with division. So these are some of the arithmetic operations, and let me now actually, uh, so I make sure that I didn't miss anything. Let me add the bit round folder. Ah, we missed one actually. Okay. Now back to the example we were just talking about. Okay. I hope this sound will not affect the recording. Because, I can barely hear myself. Okay. Now let us go back to this example. What if I want to produce an integer actually? So what's so special about division? What is the why is it producing a float? What is the technical um reason for it to produce a float in this case? Because not all numbers, if divided, can produce a whole number. It is implicit. It is built in the mathematical formula itself. Okay. So division will either produce an integer or a float. Okay. If you want to specify that you only care about the integer side of the number, the whole number, you don't care about the fractional side, okay, you can use this sign, which is the double slash. This will actually give us an integer. Yes. And if I want to make it more clear, actually, let us do it this way. And let me comment all the uh, examples so we can focus on these two only. So in the first case, we are dividing what? Number 2 over number 1, 4 and 2. And we mentioned that this will actually ignore the decimal part. So in this case, it's giving us 2. But what if we divide 5 over 2?
So in this case, it will give also because 2. Because we eliminate the fraction part.
Yeah, that's right. Yes. And you can see in this case, but what if I care about the fractional part? For me, it is important. Then in this case, I can simply use the normal division. So the other case, what is the output? Yeah,
2.5.
2.5.
Or
It is 2.5. Okay, so I think that's it for, we covered most of the, yeah, it is most of them are covered here. Okay, no problem. Let us use casting of float. just so we can be thorough, because we use casting of integer here, right? I forgot where. Maybe we use casting to string. We use casting. I think we removed. Okay, no problem. Let me clear all of this, add it to the comments, and actually try different kind of casting. We saw the casting to integer. It was very simple, and then integer, and then the string that we want to cast 24. Okay, this will give us. Okay, let me show you something. If I want to know the type of this number, okay, so we can make sure. How can I know it is actually casted to integer? There's no way for me to tell if I want to print it directly. So if I print, we were just talking about this. If I print 24 and I print 24, for me they are the same. So one way to validate the type actually is to use the type function. The type function, if you want to go to the source code, it is assertion. We call it assertion, and it is basically a way to validate that the type before you start processing or doing any manipulation on the variable. You make sure that the type confirms to what you expect. If it's not confirming, then you can simply what do the alternative scenario. And this is very common when you are dealing with third-party APIs or something that is coming from it is external to your program. It's an input, for example. Okay, like if we ask the user, and this is very common. Okay, okay. First, let us run this before we move on to when did we start? We started 11:30. Okay. Total duration. It's actually been 47 minutes. Okay, 47 minutes. Let's stop. 15 minutes. Okay. Okay. So in this case, I have a number, and I casted the string 24 to integer, and I want to confirm that the type is actually number. So I can do it this way by calling the type function and giving it the object in this case. So this type function is one of the functions that can accept basically anything. Will accept literally anything under the sun. Anything that can be typed to Python that is valid can go through this function. Okay, and it will be parsed some way or another. Okay. In this case, if I run this program, it will tell me, it is of class integer. Why? Because I casted it to integer. Now, if I do it the other way, if I say str, of course, str. Okay, it's a good case. Okay. Okay. Let's say string 25. No, it's the other way. Sorry. It's already a number now, right? So I can cast it back to a string. Okay. So I can cast it back to a string using the str function. And now if I ask it what is the type of string, it will tell me what? It's of class str. Okay. So this is a very neat way of basically asserting the type of the variable. Maybe this is less common in competitive programming because we have everything in one in the program. The program is not usually, or it is accepting input from the user, but usually we don't care about validation that much. Okay, validation is not an important problem for us in competitive programming. Okay, because we are usually dealing with a fixed input, an input that has been formatted and prepared for us in a certain way. Okay, but it's good to know about these kind of functions in Python. Okay, now I wanted to say something for yes, um, I believe it was. I was thinking about it just now. The type assertion printing. I really forgot. I had something in mind, but I forgot what it was. It was very important also. Okay, we casted integer. Let us cast float. I think, inshallah, it will come to me later. Okay. If number, I'll call it. If number, I can say float and then cast 25.5, for example, to a float. And if I assert the type of F number and print it, in this case, I remember. Okay, let us see what is the output. It is of type float, and you can see that it is 22.5. Now, float is a good example. I will ask the user to enter a float specifically. Okay, how can I ask the user? Very simple. I can just print, please enter a float number. And now this brings us to the point I wanted to talk about, which is the input function. And this is where casting becomes very useful. Okay, so what is the input function? Input, basically, once I call it this way, it will do two things. It will stop the execution of the console program, and it will capture the next input from the user until the enter button is pressed. Okay, let us see it in action. Okay, let me actually comment all of these. We just need them for now. Let me run the program. Please enter a float number, and you can see it didn't exit. Let me type anything and hit enter. And I can see that the program now terminated. Okay, but what actually happened? What happened is input captured. It is reading a string from the standard input. Okay, it is similar to CN in what's called C++, CN or readline in C++, and it is similar to in console.readline in C# also. In Java, it is similar to the scanf function. Okay, so in each language, there is a way to read the input from, we call it the standard input. The standard input, which is the terminal input. Okay, and these, by the way, are usually referred to as console applications. Console. Okay, you can call it whatever. Console, I think, is one of the most standard way of naming it. So all we are building in the programming context or now, all we did is basically creating console application, console-based application. That means they can be run through the console using the Python 3 command -u, and what it was called main. Right? And this way you can invoke the Python pipe. Okay. Okay. So it's nice to know what is the type of application that we are doing right now, which is console application. Okay, now assuming that input function actually captured the input, how can I use it in my program? It's very easy. If there is a value here, I just need to store it in a variable. Okay, and then call it user input, and then say equals input. Okay, so if I type print and I ask it what is the type of user input in this case. What do you think it will print? A string. Okay, let's see. It is a type string. Okay, what if I run it again and type 12? Yeah, meaning that the input will always produce a string and it will not infer the type of the input that you actually fed the console application. And here where our type function becomes what useful. Because type here, it will give us what? Uh, it gives the name, right? I forgot about. So I actually forgot how to fix that. Okay. 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 Again, no, then it is type of sorry. Uh, I think this is the correct way because it's a class. It will produce a class. Okay. Okay. So in this case, and this will come to it inshallah later, this double equal operator. It's basically a way of confirming that the type that the user added confirms to what I'm expecting. So if I run this program, it will tell me true. Okay, because the input will always give me a string. Okay, even if I, in this case, added numbers, even if I just use numbers, it is a string always. So if I want to do manipulation on a number, I need to cast it. I need to cast the input to an integer. And you can do this in one line, by the way, or two lines, up to you. You can either take the user input in one line and then do the casting of user input in a second line, which might be a little bit easier to read. Or a more common way actually of doing that is to do the casting immediately, which is a function calling a function. When you use nested functions like this, which is I know it's a little bit confusing, but actually what gets executed is the innermost function first, and then we have something called bubbling effect. First, the inner is executed, and then it bubbles to the outer, then it bubbles to the outer. So it will take the input, which is a string, it will convert it to an integer, and that integer, it will be converted yet again into a float. So if I tell it that, okay, can you accept that this type is a float? It will actually print, in this case, true. Okay. So this is, of course, yeah, we try to not do this that much, which is multiple function listing, okay, because it might make the code unreadable sometimes. But this, I think, it is very acceptable, actually, and it's very clear what it's doing. It is basically grabbing the input which, once that function is executed, the execution of the console application stopped. Then it's waiting for the input from the user. How does it know that the input from the user ended? By using the enter character. Once it gets an enter character added, or once the event of the enter character is captured, then it will resume the execution. Input will be converted to a string. String will be passed to the integer function, which will cast it to an integer. And then we are basically asserting if the input is an integer. Okay. Now, if I do this, uh, yeah, okay. If I do this integer, I'm forcing the input to be what? Of type integer. But what if I try to mess with the program and feed it a string? What will happen?
Either will be zero or
It will throw an error, actually, because it cannot cast. It's not able to cast. There is no representation of the string to integer. Okay. So in this case, how can I solve this? It is unsolvable. Unsolvable in a way that is, in a sense that is, you cannot expect what the user will add. So in order to fix this, we have the exception handling, okay, which is try catch. Yeah. So I have a try catch here, I think, somewhere. Or, okay, if I remember correctly, the syntax of try catch. Let's go back here. I think it's try. Expect. Okay, and then this is what I'm going to do. And this will bring us to actually to the next segment, which is the listing in Python. Okay. We'll come to it now. But now I'm asking the user, please enter a float number. Okay. And then I'm trying to cast it into float, which is the user input. And I'm asserting if it's a float. And then this is where the try catch can help us manage the execution of the program. That if something unexpected happens during the execution, the program doesn't throw that error that we saw here just now. Throwing that error, it means that there was unhandled exception. Okay, an exception that happened and we were not able to what capture it before it stops the execution of our program. So unhandled exceptions are actually a bad thing. We always try to handle any code that we expect something wrong to happen with it. Okay, try catch is one of the ways. Of course, I keep calling it try catch. It is try except here in Python. So try basically it's saying, okay, try to execute this code. This indented code. Indentation is this space, four spaces included before the line. So all this code will be executed first. Okay. If it's executed correctly, nothing else will happen. This line will not execute. If something goes wrong, then this line will be executed instead. Okay? So this is what it means to try use the try catch or the try except here. In this case. Okay, let us run this example, and I will feed it a string, and it will tell me it's an invalid input. Okay, which is correct. And if I run the program again, and I feed it a number, basically any number that is castable to float, then it will be converted. And if I feed it a float directly also, it will be converted. So this is a way of validating user input. Okay. So today we were able to cover, I think, many things. We covered variables, the print statement, the input statement, the casting, which all of them you can see they are working together. I mean, it's not it's completely unrelated. Casting is usually associated also with input. Print is used to prompt the user to ask him to add something. Print itself can use multiple data types. We talked about data types. We covered three data types. Ah, Boolean, we didn't actually print Boolean. Okay. We printed everything but Boolean. I think we printed integer, we printed float. Let us print a Boolean. So if I declare a Boolean here, so true or false equals true, and true need to be with T capital, okay, and false need to be with F capital also. This is just for your information, okay. And I try to print true or false, it will actually print the same thing. Okay, it's not like it's printing anything else. It will actually print the word true, but it is actually a Boolean value, and we can assert that again using the try function, which will tell us it is of type bool. Okay, and we didn't cover the casting of bool. Casting of bool will also do the same thing, but it is a little bit we can say I don't want to say unexpected, but there are things that can be casted to bool that will it will surprise you. Okay, if I print this one, okay, what do you expect will happen? I'm trying to cast the string one to boolean. Maybe true. Usually it is. Okay, but look at this. If I try to cast 0, no. It is actually okay. So it is, as long as it's a string, it will be truthful. String with a value, sorry. As long as it's a string with a value, it will be truthful. But if it was, I believe if it was an empty string, it will be false. This is the surprising part because usually we associate 0 with falseness. Okay. With numbers, it's the same. If I try, it's not the same exactly, but if the number is not 0, it will be truthful. But if it was 0 exactly, it will be false. Okay. So any number will return true, but only 0 will return what false, and even negative numbers will return true. So this is what is a little bit unexpected. It's the 0, the string 0, and the number 0. They are treated differently. The string 0 actually is true, or any string with a value for that matter. As long as it got a value as a string, then it's true. If it's an empty string, then it is false. For numbers, any number is truthy except for 0. So I think now, alhamdulillah, we covered everything we wanted to talk about in this lesson. Thank you all for joining. I hope it was useful. I think in the next training, we need to cover if conditions and loops.